Welcome back to Chem Talks. Today we are going to do our second installment of talking about the quantum mechanical model of the atom. Remember, this is our best understanding of what the atom looks like today. First put forth by Schrodinger, and it's based on the idea of knowing where the electrons are most probably going to be found. Remember, Schrodinger expressed this in his quantum numbers. There were four quantum numbers. There was the principal quantum number, the orbital quantum number, the magnetic quantum number, and then the spin quantum number. And all those help explain where we're most likely going to figure, or where we're most likely going to find the electrons. We call this the electron configuration. It's kind of like the electron's address. It explains where the atoms are most probably going to be located within an atom. The electron configuration is basically going to contain three pieces of information. First of all, the quantum level. That's the principal quantum number. How far away from the nucleus is. Second, the orbital shape. What type of orbital is it in? And then the third thing is going to be how many electrons are in a particular orbital. When we write on an electron configuration, it's going to look something like this. If we have hydrogen, our electron configuration for hydrogen, which is our first element, first atom, is 1s1. 1 being the quantum number, s being the orbital, and then 1 being the number of electrons. So let's take a look at this a little more closely. Like I said, it gets three pieces of information. Here's our hydrogen again. The first one is the principal quantum number. That's your energy level, and that's going to be represented by the 1. The second one then is your orbital quantum number. This is what type of orbital are we in. Are we an S, a P, a D, or an F? And then those are our first two quantum numbers. And the third piece, the number of electrons, is not one of the quantum numbers, but it is represented in electron configuration, and we put that up top. This means that in the first quantum level, which remember, there's only one type of orbital that can be in there, there's only one electron of a maximum of 2. So this is what a simple electron configuration looks like. So let's look at how to write electron configurations. First thing we need to do is identify what we call the element's address. And what I mean by this is what is the location of the last electron in that. So if we can know this, then it's easier to work to write out the whole address. It's kind of like giving directions to it. So once we know the address of the last electron, we can fill in the orbitals below it, that address. It's kind of like giving directions on how to get to that electron. Okay, and when we're filling up these orbitals, we're always going to start with the lowest orbital. That's going to be 1s1, the hydrogen one, and then we add on to that until we get to the location of the last electron. And that's what we're going to work on today, is how to write out these long electron configurations. Okay, so the first part is to figure out where the last electron is located at. Okay, so first thing we need to do is identify what quantum level that element is in. Remember, this corresponds to the row number 1 through 7. Second, we need to identify what sublevel it is in. Is it an S, a P, or D, or an F? And we can simply tell that by its location on the periodic table. And then the third thing is we need to identify how many electrons are in that orbital for the particular element. Remember, each orbital can hold 2 electrons, and depending on what type of orbital we have multiple positions. Remember, S has 1 position, P has 3, D has 5, and F has 7 for a total of 14 electrons in F. So let's take a look at this a little more in depth. So let's say we're trying to identify the electron configuration or the address for this element right here in star. First thing we need to do is figure out what quantum level. So if we look here, it's in the 5th period, 5th row. So the quantum number is 5. Then we need to identify what orbital it's in. Okay, well, it's in this blue block here, which is the P. So it's in the P orbital. Excuse me. Then we have to figure out how many electrons in. Well, remember, P has 3 positions, two electrons per position, so we get a total of 6 electrons. And if we count over, this is 1, 2, 3, 4. So our address for this particular electron will be 5, P, 4. So this address of this final electron would be 5p4. Well, once we know that, that's kind of like your home address. I live at 2236 First Street. Okay, no I don't, so don't come looking for me, but that's kind of like giving your house address. Now, if I wanted to get you there, I'd have to give you directions from your house to my house, and that's what the rest of the electron configuration is. So giving the directions or filling in the orbitals. So what we have here, this is a cheat sheet. Each box represents the final electron position. I think the last one we said was 4p or 5p4 was right here. Okay, so what we have to do now is to give directions how to get there. Well, you're starting at your home, which is the lowest energy level right here. So we must go across the top row, then across the next row, and across the next row, and so on until we finally get down here to 5p4, which is where you're located. We're there, so we don't need to write any more directions or give any more directions once you're there. Okay, so what we see is this is the order that the electrons orbitals fill in, or kind of the directions from your home. We always fill 1s, which is the first row, then we go to 2s. Remember, since we're in the second quantum level, we have two shapes. We have 2s, 2p. We go to third quantum level. Well, there should be three shapes. We should have 3s, 3. We should have s, d, and p. But we find it's 3s, 3p. We don't have 3d. We'll talk about that why. And our next one is 4s, and it continues on from there. Okay. So what you do when you're writing an address, you start at the very lowest and fill it up until you come to the location of your final address. So let's practice this for carbon. First of all, we must identify carbon on a periodic table. Remember, carbon is C. That's right there. So let's look at where we're going to find this. Once again, here's carbon highlighted in yellow. If we come over here, we are in this row, which is 1, 2, second quantum level. We are in the P block right here, okay? And we are in the 1, 2, second electron position. So our quantum number or electron configuration from this should be 2p2. Let's see if we're right here. Here's carbon, 2p2. All right, we got the final address. Now what we have to do is give directions on how to get here. Remember, we always start here at the beginning with hydrogen, which is 1s1. So let's look how we would write this. We'd fill up the first row. So we're going to fill this up, 1s2. We move on to the second row. We're going to fill the 2 s's, and then we'll get into the 2p's. So let's look what this would. Let's see what this would look like. So we said our final address for this, for carbon, is 2p2. To write the complete address and directions, we start at the beginning. So it's 1s2 for our first row, 2s2, and then 2p2, which we got to carbon right here. Pretty simple. Let's try another one, a little harder one. Okay, let's practice with sulfur. First, let's identify sulfur. It's S. Here it is in our right here. So let's go to our next chart here. It is right here again. So let's go over and figure out what quantum level we're in. 1, 2, 3. This S here just means we're in the S block. Okay, now let's see. Well, sulfur is in the P block, so it's 3p, and we are 1, 2, 3, 4 over for electrons. So it's going to be 3p4 should be our address. Let's check it on another chart. And here we go, 3p4. Now we need to write its address, or excuse me, write the direction. So we fill up the first block, then the second, and then we fill to here. So let's see what this would look like as we write it out starting from the beginning. We have address 3p4, so we got to fill in everything below. It's kind of like building a skyscraper, right? You don't start with the penthouse. This would be our penthouse. No, you got to start with the ground level, the basement, and build up one story at a time. That's what we're doing. We're giving address. So it's 1s2, go to second level, 2s2, we go through there, we got to drive through the p's, 2p6, we drive through the third level, 3s2, and then we come to 3p4. Now this is not how we write it. When we write the electron configuration, we're going to write it out something like this. This would be the complete electron configuration for sulfur. Okay, let's try a couple practices. Pull out your periodic table and follow along with me in this. I'm going to go through these pretty quick. Pause as you need to. But hydrogen we already did. That's our first one, so it's going to be 1 electron. It's 1s2. To the right of it is helium. Now helium, if we looked at it at the top, would look like it's in the p level. Remember, each orbital can hold 2. So we got to actually picture helium being right next to hydrogen, and its electron configuration says 2 electrons is 1s2 because it's still in there. Let's drop down below hydrogen to lithium. Lithium is in the second quantum level. It's in the s and it's in the first position. So it has 3 electrons. It's going to be 1s2, 2s1. Well, what's next to lithium? Beryllium. Okay. Well, we're just adding 1 electron, so we're just going to add 1 more. Where do we add that? Well, we add it to the 2s. So the correct one for beryllium is 1s2, 2s2. Now let's look to the right of beryllium where we have boron. Okay. Boron has 5 electrons. Well, the first 2 are going to go in that first quantum level, 1s2. Then we have 2s2. If we look to the right, then we have 2p1. A good way to check yourself is take all these electrons up here, add them up. So 2 plus 2 plus 1 gives us 5. And that matches the number of electrons. Remember, how do we figure out the number of electrons? Well, in a neutral atom, the number of electrons are equal to the number of protons, and number of protons is our atomic number, which is given in the periodic table. Okay, how about carbon? Well, we already did this one, so I'm going to go through this one really quick. Next to the carbon, then we have nitrogen. It's going to have 7 electrons, so once again, we're going to fill them up. We find its final resting place, which is its final address, which is going to be 2p3, and then we have to fill in everything below that. So we get 1s2, 2s2, 2p3. Next to that, then we have oxygen. Well, we just are adding 1 more electron, right? Because it's atomic number 8, which gives us 8 electrons. And so we just add 1 more electron to the p's. Because remember, p's can hold up to 6, or only up to 3. So it's 1s2, 2s2, 2p4. Okay, I have 2 more. I want you to try fluorine and neon on your own. Write these down, pause this, write them down, and when you get them complete, come back and let's check them. Alright, now that you got them written down, fluorine has 9 electrons. Okay, so it's 1 over from oxygen, so it's electron configuration, it's going to be 1s2, 2s2, 2p6. Well, neon's to the right of that. Actually, that's wrong. It should be 2, right? So we add these up. It's 2, 2, that's 4, plus 6, that's 10. That should actually be 2p5. 2p5. Please note that's a mistake. Okay, neon, on the other hand, has 10 electrons, right? So it's 1 to the right of fluorine, so it should be 1s2, 2s2, 2p6. Okay, so you get an idea how this is going. If you're a little confused, don't worry. When we practice in class, you'll get a lot better.